folks. Welcome back for more Stationeers. Sorry for the late video this week. The 4th of July holiday kind of slowed things down a bit. So today, we are finally starting work on our advanced furnace. So let's go ahead and get geared up and we'll go take a look.
Pressure critical. Temperature critical.
There we go. So off camera I did a little bit of this and that. Obviously got parts ready for the build for this episode. I also went through the greenhouse and did one final harvest, at least for now. So it's empty right now. We've got plenty of oxygen and plenty of food. Also scavenged a bit of stuff from over here, including an APC from this airlock and some of the piping that was here. All this Atmo has been vented into the main system now. But let's get started on the project. So the first part of the advanced furnace is deciding exactly how you want to go about building it. I decided to go with a design that I've seen Cows Are Evil using it. That's where I first encountered this design type, although I don't know where he picked it up from. But basically, we take the advanced furnace and we have 3 tanks, a tank of hot gas, a tank of cold gas, and then a waste tank. And we mix those in various ratios to get the temperatures and pressures we need. So we're gonna go ahead and get started. First we need to frame things out. I did level this off already, so there's that. I'm gonna just go ahead and build out the frames for the whole build. Some of these are going to be fully built out, but most will be left in an open form for now. I think that's going to be all of the frames for now. Not sure yet what's going to happen over in this area. I guess before we go any further, I should probably give a rundown on the parts here. We've got the frames, and it was about a stack and a half of steel frames, and most of a stack of steel sheets. 7 chutes. There's our advanced furnace, electronics parts that we need for the advanced furnace. This is our old basic furnace. I've torn it down and we're going to be using it as part of our build tonight. A couple of logic IOs. These are actually just a temporary thing, but we'll get to those later. An IC housing and the IC10 chip. This is going to control all of this. An APC and a battery. I'm going to put all this on its own individual circuit, mainly just to keep things easier to manage. Sort of as an afterthought, I didn't do this during my testing, but I've got 6 gas displays and 6 consoles, so we'll be able to monitor the 3 tanks a little easier. I've also got a couple of stacks of cable coils as well as a full stack in my tool belt. We've got 5 volume pump, a turbo volume pump, a digital valve, 3 insulated tanks, 3 stacks of insulated pipe, 2 stacks of regular pipe, 20 radiators, and then the rest of this is just for helping keep things straight with color coding. One thing worth mentioning, I'm deviating from the color standard that I've been using because this is going to be its own isolated system and I need multiple colors to help keep everything straight. So maybe not as many parts as we have in some of our larger projects, but this one's going to be a little more complex, at least on the programming side. So the first thing we want to do is we want to get the advanced furnace in place. And it's going to live right here. Now, its control panel, it's sort of designed in such a way that its control panel will protrude through the wall. It's a little offset from the frame, but that allows the frame to insulate it to keep its heat and pressure stable. And what do we need to build that? There's our electronic parts. There it is. So the advanced furnace works similar to the basic furnace, but it allows us to do the super alloys. We've got a power switch, activate button, pressure and temperature gauge, the open mold lever. That's all familiar, but one thing that's special about this furnace is it has 2 integrated volume pumps that are part of the system. So we'll come to those later, but that's the main difference as far as the functionality of it. Now that we've got that in place, let's go ahead and get our tanks. Now these will be high pressure tanks. I don't like having them necessarily that close to this part of the building, but it's kind of necessary for this build. So this one will be our hot tank. This will be our cold, and in the middle will be our waste tank. And for coloration on those, the waste is going to be purple, which is our current standard. And we're going to use blue for the cold side. And red for the hot. Now, the way this will work, because it has these volume pumps that are part of the furnace, we're going to have the input here, and the volume pump can move up to 100 liters per game tick. 100 liters is the same volume as 1 pipe. So this pipe will be evacuated every game tick if this input pump is on the maximum. Let's go ahead and get some of these colored up. save back some. Now we have these 5 volume pumps. They are going to be used in a couple of different ways. First, they're going to be used to send gases into this pipe for the furnace to pull in. And they're also going to be used to connect the waste tank to the hot and cold systems. And the reason for this is different for each one. The hot system will be fed from a furnace. It's going to be hotter than we really want it to be. But by adding cooler gases from the waste tank to the hot tank, we can lower that temperature. On the other hand, the cold side, it is supplied by the waste tank. However, we want its temperature to be lower, so it's going to have a cooling loop. So this pump will bring waste gas into the cold side to supply it. This pump will bring waste gas into the hot side to cool it. In theory. Let's go ahead and get the feed to the furnace. Okay, so the cold side is going to be fed from that. And the cold side temperature will be maintained with a cooling loop and a digital valve to control it. Let's go ahead and set that up. Alright, that's got that ready to go. And I think that's pretty much it for the cold plumbing. Let's go ahead and name this. That's a more logical name. We're going to leave both of those set on 50 liters for now. If both of them are turned on and the input pump is turned on at 100 liters, then we don't blow up the pipe. Yeah, that'll work.
Hydration critical.
All right, it's got the waste system plumbed in as well. It's fairly straightforward. This gas is going to be recovered once this tank gets above a certain pressure, and it'll go back into our hot waste system. Which kind of brings me to another topic on this. As I mentioned, I first saw this style of furnace in a Cows Are Evil video. However, my build is not going to be directly based on his. It will work the same way, however, his is the details of his are different. Part of this is because my fueling system is different. But also, I just didn't really want to do a direct copy of what he did. I wanted to take the concept and make my own take on it. So the primary difference, as I mentioned, the fueling system is different. That has a few downstream changes, though. In his system, he was mixing at the point of use, mixing his fuel. In my case, I have a pre-mixed fuel system that we built in the last episode, which is all controlled here. I didn't need to bring that tomato soup with me. But this fueling system, as I said, his is mixed at the point of use. Also, his system recovers hydrogen and oxygen, and he uses his filtration system to pump his hot gas into the hot gas system, whereas I'm using the turbo pump, and I'm not recovering any unconsumed oxygen or volatiles. I'm just leaving them in the system because they'll be filtered out later once they go through the hot waste system. So yeah, let's work on the hot side now. The basic gist of it is the fuel goes to this furnace, and then this furnace will ignite the fuel, and it'll immediately be pumped out of this furnace and into the hot system. I'm going to put it in there upside down because all this system, all this furnace is really doing is just igniting gas. I think I want to move that up. I want to keep it centered in this frame so that I can seal up that frame without having to seal up all the rest. Let's go ahead and bring our fuel over here. I believe we're going to want that there. Well, I should finish building it out. And that's got it. So an interesting thing about the basic furnace is it actually has a valve in it on the output side, or rather on the input side, that if you have fuel going into the input, you ignite the furnace, it doesn't allow the fuel remaining in the pipe to be ignited. On the output side, it does not have that. Again, this is another place where I differ from the Cows Are Evil build. In his case, he was taking advantage of that. However, in mine, I wasn't. In my initial design, I had allowed this furnace to remain a part of the hot system. However, that caused some problems with the automation, and I realized that I needed to use the turbo pump to evacuate that hot gas into the hot system. I'm not sure if I can explain that adequately without, well, once we get to the code maybe. But to begin with, let's get the fuel line down. Gonna pull out this frame. Well, that is not exactly where I wanted that. But I think it'll do. And let's grab our turbo pump. Pretty sure I had this in the wrong place. I think I need to move all this up by one. Okay, there we go. Well, let's go top up our jetpack.
Jetpack critical.
I believe I mentioned in previous episodes that the new update seemed to improve performance during the only time I had performance issues, which was sunrise. However, the stuttering seems to have somewhat returned. I'm not sure why that is. Set these to 100 liters. And this one we're going to go ahead and set to 1,000. Because we want to pull out of this as quickly as possible once it's ignited. Alright, let's grab our orange paint. Let's see what we're missing. Cold side should be good. Fuel to the furnace. Evac pump. Hot side looks good. Yeah, I think we're ready to do some wiring. And we'll start by bringing all of these tanks data lines together. And that's got that pump in there. Okay. Get these pulled in. I think we can actually run this way. Alright, let's take a look and make sure everything's connected to each other. I think that has everything tied together. Now, all of this is going to be on its own circuit. I think we're gonna set that up. Maybe right here. And this isn't going to have its own. It's not going to have its own transformer. It's just going to tie into this wiring right here. Yeah. This should all have power now. I believe that has power. No, no, it doesn't. This lower section is not wired in with the rest.
Hydration critical.
Okay. Now there should be power. There we go. One more.
Power low.
There we go. Let's go have us a sip, get a battery. We'll come back and work on this some more. Alright. So what do we have left? I think most of the plumbing and wiring is done. Everything is named. Just a little bit more. Let's get our IC housing. Here, go ahead and name that. Now, the furnace itself and these two pumps leading into it, those actually are going to be on a separate circuit. I need to change this up. Yeah, because the later project, or the latter half of this project, is going to be controlling this furnace. And doing that will be controlling those two pumps back there and the two pumps that are part of the furnace. The IC that's going to go here, it's going to manage these tanks and the plumbing here. Its job will be to keep cold gas here, hot gas here, and waste gas here. And of course later on we'll be tying this into the waste system. But that'll be a separate project, I think. So, for now, these are going to be tied in to the power from this. But that's a temporary arrangement just for testing. So this one does not need to be connected here. This will just be our temporary tie in here. Okay. Now, in order to test this, we need to be able to turn these pumps on and off. And again, this is temporary. We're going to use a couple of logic writer switches. And the reason we need these is because we need to seal this block up. And once it's sealed, we can't reach these pumps. We will give them names for now, though. We'll even color code them so we know what we're doing. Okay. So, guess we need to seal that up. And now it's time to look at our code for this. Let's bring up our function window and our library, and we're going to load that to make sure it's up to date. So, it's a little chatty in the comments, and I will be uploading this to the workshop if anybody wants it. We'll just go through this fairly quickly. First thing, we set up the devices. We've got the 3 tanks: hot tank, waste tank, cold tank. We have the fuel pump, which goes to the basic furnace, and the hot cooling pump, which goes from the waste tank to the hot side, and the cold filling pump, which goes from the waste tank to the cold tank. Now, we're using batch commands because we're out of pins on this IC housing, which is another reason to use a turbo pump for the furnace evacuation pump. The furnace itself, we need to access it, so we're using a batch command for that, and for the valve for the cooling loop on the cold side. Each of those is isolated behind the APC, and there is only the one valve, the one furnace, and the one turbo pump. So we've set up defines so that instead of using the hash code for those devices, we can use a meaningful name. In case you're wondering how you get these, you can go into your Stationpedia with the F1 key and say, like, the digital valve. There's the prefab hash for a digital valve. And you just click it and it'll copy it to your clipboard. Note that it's the digital valve and not the digital valve kit, which has a different hash code. Now you can use batch commands just like with the batch writer with the logic chips. You can use batch commands to control multiple devices of the same type that way. But what we're doing is we're kind of just using it as a way to get extra devices under control by sending a batch command to all the valves, but there's only the one. The next section, we define some more numbers. The target pressure, this is the target pressure we want to have in the hot and cold tanks. I've set it to 5,000 here, but we'll be increasing that later. It takes a little time, we'll see in a moment. Our maximum temperature, this is the temperature that we want to set as our target for the hot side tank in Kelvin. And the minimum temperature is how cold we want the cold tank to be. When we first ignite the gas, the fuel, it spikes up to 2000, 2200, but we'll cool it down. I've got some registers that I'm using longer term, registers 0 through 5, for the hot tank temperature pressure, the cold tank temperature and pressure, the temperature and pressure in the furnace. This is the basic furnace. So here's where the loop starts. I have a yield in there just to give it a break. We read in the temperature and pressure from the hot tank and the cold tank. This is another place where I've deviated from the design in the Kaiser Evil build. I do recommend checking out his video. It's a 2-part build. It's very informative, and he goes into some detail on particularly his code for this, as well as automating the furnace. But again, my build is different from his, so, and my code is different from his. So once we load in the temperatures and pressures from the hot and cold tanks, we come here to deal with the cold tank. Now, register 8 and register 9 I'm using for Boolean values, ones and zeros, true or false. This is a command I don't think I've used in a previous episode. It's set less than, SLT. We'll look at that here in the function. So what that does is the first register will be set to a 1 or a 0. It'll be set to a 1 if this value is less than that value. So if the cold tank pressure is less than our target pressure, this will be set to a 1. And then we use the save command or store command to tell the cold side filling pump that feeds from the waste tank to whatever value register 8 is. So if that pressure is less than our target pressure, that'll be a 1. It will set the on variable for that pump to a 1. Otherwise, it'll set it to a 0. Then we handle the temperature. Again, we reuse register 8, set greater than, which is the exact opposite. So this will be a 1 if the temperature in that tank is higher than the minimum temperature that we want. And then here we use SB, which is a batch store. Works pretty much just like the store command for this volume pump here. But again, we're using a batch command, and so we're storing it to anything that is a valve. And in this case, there's only the one valve. It sets it to a 1 or a 0. The valve's on state if it needs to be turned on to cool it. On the hot side, it's a little more complicated. The first thing we do is we reuse register 8 again. If the temperature in the hot tank is greater than our max temperature that we want, it will turn on the cooling pump to send cooler gas from the waste tank into that. Here, if we're under our target pressure, it will set register 8 to a 1. And we also use register 9 if the furnace pressure is less than 1,000. This is to prevent it from attempting to fuel the furnace if there's already something in the furnace. But I didn't want to set it to 0. I didn't want it to be that slow. The reason for this is you put fuel in the furnace, you ignite it, now you've got a little oxygen and a little volatiles left, and mostly waste gases, and a lot of pressure and heat. if you continue to feed fuel into it, the fuel will ignite again, but only once the oxygen percentage reaches 5%. And the more gas that's in there, the more fuel you have to put in to reach that 5% ratio, and therefore get ignition. This is also why we need the evacuation pump, because then it will pull it out of the furnace so that we can more readily get to that 5% ratio. So both of these will be set to 1 if the pressure is less than the target pressure in the hot tank, and if the furnace pressure is less than 1,000. Then we have an AND command. What AND does is it sets this register, the first one, to a 1 if both of these are a 1. So if both of these conditions are not met, this will be a 0. And then register 8 is used to set the on state of the fuel pump. So if both of these are true, if we're under our target pressure in the hot tank, and if the furnace is less than 1,000, or 1 kilopascal, or 1 megapascal, sorry. If both of those are true, then it will turn on the fuel pump and send fuel into the furnace. Now here, we're using another batch command, but this is the reading batch command. And it uses, because it could theoretically be multiple devices because it's a batch command, there's an additional parameter to this. So let's look at the LB command here. So this will load a variable from all of the devices that have that hash type. So in this case, the furnace hash type, which we defined at the top. So it loads into the furnace temp register the average of all of the temperatures of all of the furnaces on this network. Now there's only the one, so. And then we do the same with the pressure. And this is for the evac pump, the turbo pump. If the furnace temperature is greater than 500 degrees, meaning that we've had ignition, and if the pressure is greater than 0, meaning that there is something to pump out, if both of those are true, then it will turn the turbo pump on and pull the hot gases out of that furnace and into our hot side tank. And lastly, we're using a batch command to send the activate command, or set the activate variable of the furnace to 1. We're just sending that activate
Critical.
regardless of whether there's fuel in there or not. I could check for a correct fuel ratio if I want, but in reality it doesn't really matter. If we activate the furnace and there's no fuel in there, it's not really it's not a problem. And then we jump back to the start. So let's export that. Turn it on, get our error, turn it off, and we'll set up our pins. The hot tank, the waste tank, the cold tank, the fuel pump, the pump that sends cooler gas into the hot side, and the pump that feeds into the cold side. Now, when we turn that on, that should begin by turning on the fuel pump and igniting the fuel inside the furnace. Now this is, we look here. Hot tank has 2100 Celsius. That's, I think what we're looking for is about 1500 Celsius, because remember the IC code uses Kelvin. So it's attempting to cool that by using gas from the waste tank. However, there's nothing in the waste tank because nothing's gone through the furnace yet. Likewise, the cold tank is below the target pressure as well. It's trying to fill it from the waste tank. But again, nothing in the waste tank. So, we're going to let that go for a minute. This is going to try to get up to 5 megapascals. And we'll go have us a sip, and then when we come back, we'll work on getting some gas in those other tanks. Okay, so we are back at it. So in order to get gas into the cold tank, it has to come from the waste tank, and that has to come from the furnace. And in order to get this to the temperature we want, again, it has to come from the waste. So let's take a look. The input is at 100 liters. The output is at 50. Let's go ahead and turn the output off. And we'll just put some hot gas from that tank into the furnace. Oh, I forgot to set this up. Should probably do that. Alright. Set this one to the hot furnace input pump on variable. And this one's set to the cold furnace input pump on variable. Now we can put some hot gas in there. And again, this is set to 100 liters, which means that however much we put in that, as long as both of those pumps are kept at 50, if both are turned on, we can't possibly have more than 100. And when we turn this off, we see that the temperature and pressure remain stable. That's because this furnace is insulated by this frame here. So now we can pull this hot gas out by turning up the output pump. And now we can see we have gas in the waste tank. It's starting to fill the cold tank. It's starting to cool the hot tank. Although it can't cool it by much because it's the same temperature. It's the same gas. Now our cold tank is being filled, and of course it's too hot because it's 2100 Celsius. So it immediately turns on the cooling loop, pretty rapidly cools it down. Now, in order for this to successfully cool that, we've got to get some cooler gas in there. So what we're going to do, now we're going to feed the furnace, which is now almost empty. And we're going to feed it from the cold side. There's not nearly as much gas in that side yet, so there's not much for the volume pump to pull in. But turn that input off, turn up the output pump. Now we can see the waste tank is much colder. And it can begin to cool this down, as. However, there's not a lot to work with yet. So what we have to do is we have to keep bringing hot gas into the furnace, venting it back out, getting it into the cold side where the cooling loop can cool it, bring it back through the furnace to cool the waste tank, which can then cool the hot side. So I believe I will work on that. This is still not quite reached. Now what's going on here? Fuel pump is on. Ah, there's no fuel in the pipe. I forgot to turn the fuel valve on. So now we can see that we have fuel going in. This vents it out. Once it gets vented out, and actually what's happening is it's venting it, but as it pulls it, that remaining oxygen and volatiles, the ratio changes as it's pumping gases out of the furnace, and eventually we get to a 5% oxygen again. So it reignites just because of the temperature. But once we reach a certain level, it will pull from the fuel pipe, bring more in, and reignite it. So to make it easier to monitor all of this, let's go ahead and set up these consoles. I'm not sure yet what sort of interface I want here. But I think for now, I think I'm just going to set these up across the bottom of that upper row. Yeah, I think that'll work up there. And we'll just put them in line with where the tanks are. don't think I like that. Let me take a moment to work this out and maybe recover my voice a bit. Okay, I've decided we're just going to do a temporary arrangement with these for now until we figure out what our interface is going to be. I also went ahead and set up these chutes. This is also temporary, but for now that'll allow us to do some testing. So let's go ahead and set these up. And I need to get some glass sheets and my data disk. So this will be our hot side. Waste tank. And our cold tank. Alright, there's our hot tank temp and pressure. And the waste tank. Alright. And then again, this is all just temporary. I don't yet know what my user interface for this system is going to be. So we can see that we've got our minimum temperature, which was 5 megapascals, and a little to spare. Fuel pumps off, evac pumps off. This is ready to go. It's just too hot. I think the 1800 Kelvin that we've targeted for is about 1530 something? 1523? Can't remember. But still too hot. But there's nothing in the waste tank to cool it with. Let's bring in more cold. And we'll just leave our output pump running. So that's going to pull in cold gas from here back into the waste tank. Our cold tank is still not at the 5 megapascals target, so the waste tank is pumping it straight back into that. But some of it's also going into the hot side in an effort to cool it down. I think what we're going to have to do is actually bring in from the hot side to get this sufficiently filled so that we have enough cold gas to work with to cool this down. I could have pre-filled this tank with some cold gas and saved on some of the fuel that I'm using to feed this system. But this allows me to test the mechanisms and make sure everything's working as well. And it would kind of be a hassle to have a temporary fill. Let's bring more hot in. Leave the output maxed out. Now there's plenty of hot gas, so it's actually filling the furnace pretty quickly. Remember that volume pumps work faster the more volume they have to work with. So now we're getting hot gas into the cold tank. Our cooling loop should be on. Yep. And we've also pulled this below the 5 megapascal limit. So the fueling and heating is on. And we'll turn that off for a minute. Let the output pull that to the waste tank. Again, we're coming from the hot tank into the furnace and straight to waste. So the waste is very hot now. But it will continue to feed the cold side, and then we'll run more of that cold gas back through to cool that. And eventually we'll end up with cold gas here, hot gas here, and something somewhere in the middle in the waste tank. Something cool enough to cool this down, and enough of it to fill this back up. We'll go ahead and bring some more cold in. Want to make sure that this output is turned up. I don't want to allow this to get too pressurized, although that doesn't seem like much of a hazard right now. And of course, we always want to keep the input pump at 100 liters. We can turn on both of those pumps and still clear that pipe. All right. Well, I think it's working correctly. So I think that might be where we'll call it. Would like to maybe test it out though. I just don't think I've got enough gas yet. And we're going to need to mix some more fuel. I will probably need to make a mining trip to get more volatiles. Getting a little low. But for now, I think that's probably a good place to call it. Going to keep feeding this hot gas in pulling it out, putting it into the cold side, cooling it until we get these filled up. I do believe that I will probably set the target temperature or target pressure to something like 20 megapascal. Just change the, and that will give us a useful amount of gas that we can work with for actual smelting. Export the code. Turn it off and back on just to reset it. And hopefully we have enough fuel to get this system fully pressurized up to 20 megapascals in both sides. I'm not too worried about it being super precise, as long as it's somewhere in that neighborhood and the temperatures are somewhere close to where we want them. Yeah, I think that'll do it for now. And maybe next time we'll work on the user interface and maybe do a little super alloy smelting. Possibly look at our options for automating this, so that we can balance the hot and cold feed to get the temperature and pressure we want for whatever alloy we want. In the meantime, I appreciate you hanging out. I hope I've explained things as clearly as possible, and I hope I was understandable with my voice trying to give out on me. I'm not really used to speaking as much. But, yeah, we have an advanced furnace now. Now we can do some really cool stuff. Questions, comments, suggestions, ideas for future projects. I'd love to hear from you guys. I always try to respond to all the comments that I can. But till next time, thanks for watching.